Alright, so very good evening to all of you. I welcome you all on this doubt clearing session of Stereochemistry. So I'm really sorry for the delay. Actually, I was taking one's class on Plus, so like the class got extended. So I'm really sorry for this delay. So today in this particular session, we'll be discussing all your doubts from the topics which we had covered in Plus classes for Stereochemistry. We still have to cover some topics of confirmation analysis, but let's we'll be first discussing the points from whatever concepts we have discussed. Then we'll be discussing the concepts from confirmation analysis. Okay, so I hope everything is working fine now. Let us start with our session. So you can ask your doubts one by one in the comment section. If you can write it, you can let me know in the comment section. Or if you have any pic to share or any image to share, you can just send that image in the respective group. Okay. So I hope now it's clear. Ajit, the voice is not echoing now. It's fine. Little bit echo. Okay. Is it like better from the previous voice? I don't know why. Why is it happening? Everything is like fine from here. Is it better? Is it better? Like, can you manage it, or like it's creating a lot of disturbance? Okay, great. So let us start off with today's session. So like what you have to do, you have to ask your doubts, and meanwhile others can just solve some questions that I'll be giving you in this session. Okay. So before I start off with this session, so like please make sure you enroll in Unacademy Space Jam Accelerate Test. So like winners from each category will be eligible to get up to 100% scholarship on a plus amount. Okay. So this is like the next date or next details for your Unacademy Space Jam Accelerate Test, that is 9th of May 2021 at 11 a.m. Okay, so don't forget to enroll in this course. Let us take very first question. So this is your first question. You can start solving this question, and meanwhile you can ask your doubts too from stereochemistry. Okay, is it like it's creating a lot of background noise? Okay, is it creating a lot of background noise? Okay, like just let me know if like it's creating a lot of background noise. I'll fix something from here. Okay, so just give me a minute, then I need to stop this session to. Okay, so I hope now it's better from the previous voice, and it's like audible. Is it audible now? Is it audible, everyone? Am I audible to you? Just quickly let me know in the comment section if my I'm audible to you, so that we can start off with today's session. Okay. Alright, so what actually we have to discuss in this question is, see, I'm just writing out each and every molecule over here. So this is the molecule. Okay, diagram is not clear, no issues. I'm just drawing each and every molecule. Okay, so pay attention. This is your first molecule. This is your first molecule. I'm just writing each and every molecule. Pay attention. You have pH and nitrogen and this bond. Then you have pH over here and Me over here and a positive sign over here. Okay, this is your first molecule. And second molecule I'm writing over here. Second molecule is, this is your second molecule. Okay, and this is your last or the third molecule? This is your third molecule. Okay, so you got three molecules now. You have three molecules. So what exactly you have to tell? So among like three compounds A to C, so this is A, B and C, which can exhibit optical activity. So this is the question, which can exhibit optical activity. This is the first molecule, this is second molecule, and this is third molecule. So you need to tell which can exhibit optical activity. Okay, so it's a easy question. Just use your concepts whichever we have discussed in session and try to give your answers for this question. Okay, so you got three molecules. This is first molecule, this is second molecule, and this is third molecule. If image is not clear, you can look from these three diagrams. You got three molecules. It's easy question. You need to apply the concepts of optical activity. Okay, so 1 minute for this question. See, this is also not clear, right? This is like I have like just drew it right now with pen. I hope now it's going. This one is clear at least. Or which molecule is not clear? Please let me know. I'll again draw it. Clear. Okay, so let us discuss this question now. So it's very simple. See, if I take first option, okay, so among A, C compounds which can exhibit optically activity or optical activity. Okay, so for optical activity, you should not have plane of symmetry, you should not have center of symmetry, you should not have alternating axis of symmetry. Okay, so these are the conditions for optical activity. Great. So if I take this first molecule, can I say this nitrogen is optically active? Can I say this thing that Walden inversion is absent over here because nitrogen is having positive charge? So due to absence of a lone pair, Walden inversion is absent. If Walden inversion is absent, so nitrogen is sp3, hybridized nitrogen with four different side atoms. So with this nitrogen becomes a chiral center. Can I say this thing? This nitrogen is a chiral center, yes or no? So if this nitrogen is a chiral center, so with this compound is now optically active. Can I say this thing? Nitrogen is a chiral center, so this compound is optically active. Okay, so definitely this first compound is optically active. If I take B molecule, okay, so if I take B molecule, first I have to convert B molecule to Fischer projection. And how I'll be converting it? We got CH2OH, CH2OH, two chiral centers. So this OH is going to be right inside, then you have hydrogen. Hydrogen is going to be left inside and OH. Can I say this thing? There is like plane of symmetry present over here. Can I say this thing? Plane of symmetry is present over here. So due to internal compensation, this molecule is optically inactive. Yes or no? This molecule is optically inactive. Okay, so let's go to the third compound, that is option C, sulfur. Hybridization over here is sp3, right? How many electrons you have for sulfur? You have 6 electrons. Okay, so one electron is over here, one electron is over here, one electron is over here, right? So it must be a double bond. So you have 3 electrons over here, so like you have lone pairs present on it. So there is like one lone pair present on it. So with this, what can I say? That this sulfur is basically right. So just quickly let me know, sulfur is optically active or inactive? sulfur is optically active or inactive? Yes, everyone, sulfur is optically active or inactive. Yes, so apply your concepts and tell me sulfur is optically active or inactive, right? Okay, so what we have to understand over here is, if I take this molecule, so it's going to be optically inactive because CH2OH and CH2OH is present over here. So like if I convert this molecule, OH is going to be left and right inside, and this OH is also right inside. Okay, so this group and this group is same, so you have internal like plane of symmetry in this molecule. So with this molecule becomes optically inactive. Okay, right. So if I take this sulfur, it's going to be sp3 hybridized. Do we have 4 different groups? Yes, we have 4 different groups. Okay, so but what we have to look over here, see, this compound is given that you have sulfur, one bond is given over here, right? See, it should be double bond O, right? If it's like double bond O, I can break this into sulfur positive and pH and this bond. Okay, so how many electrons we have for sulfur? We have 6 electrons. Okay, so one is here, one is here, one is here, right? So 3 are left, but there's a positive charge, so only 1 electron. So we have a lone pair over here, right? Okay, so if we have a lone pair over here, so we can say it's optically active molecule. Okay, it is optically active molecule. So I hope this question is clear to all of you, right? Great. Okay, so if you have like any doubts from this session, so please ask your doubts also, so that like you can revise your topic. This is next question. This is your molecule. You need to find out total number of chiral centers present in this molecule. Okay, so your comments are coming in time only. So this is your molecule, and you need to find out total number of chiral centers present in this given molecule. Quickly, everyone. So you need to find out total number of chiral centers present in this molecule. Okay, great. So let us start solving this question. So you can start from any end, from left hand side or right hand side, doesn't matter. Okay. So if I start from here, definitely you got 2 hydrogens over here. So this is not going to be a chiral center. So this is not a chiral center. This is not a chiral center. This is not a chiral center, this is not a chiral center. So let's move on to this carbon. This is one group, this is second group, and this is third group. Can I say these two groups are identical? If I go over here, I'm getting this carbon, right? These two groups are identical because you can see like there's a plane of symmetry over here. So this left hand side and right hand side, they are identical. Okay, so if that is the case over here, so this becomes, right, this is not a chiral center. Okay, this is not a chiral center. Let's move on to this carbon. Is it a chiral center? No, it's not a chiral center. You have two hydrogens attached with it. Okay, if I go to this particular carbon, this is one group, right? This is second group. Definitely these two groups have different environment. This is third group. Now this is like sp3 carbon with two hydrogens. If I go over here, I'm getting 3 degree carbon. If I'm going over here, I'm getting 2 degree carbon. So definitely all three groups on this carbon, they are different. Okay, so can I say this thing? This is first chiral center. This is our first chiral center. Okay, this is going to be our second chiral center. Definitely this is going to be third chiral center. Okay, next is, this is going to be fourth chiral center. All right, next is, this is going to be fifth chiral center. Yes or no? Right, this is going to be fifth chiral center. Next is, can I say this is sixth chiral center? Can I say this thing? This is sixth chiral center. So how you getting 7? How you getting 7? Yes or no? Anyone who can say, like anyone who is getting more than 6 chiral centers. So which center like you have included? You're giving 7 as answer. So which center you have included in chiral center calculation? Can you please tell me which center you have included in like your answer, that is 7? So like we are short of one chiral center. So can you tell me which center we should include in calculating chiral center? Anyone? Right, so there is no other, right, there is no other chiral center. See, it's not a concept of like plane of symmetry. You can just analyze this situation, right? You can just analyze this situation without plane of symmetry. If I go to this side and if I go to this side, these two chiral centers have same symmetry, right? If I go to this side, I'm getting this particular carbon. So like there is no first point of difference over here. If I go to this side, I'm getting this carbon. If I go to this side, I'm getting this carbon. So like in this case, this ring, right, these two carbons and these two carbons, they have similar environment. Okay, so I can say this thing, this is not a chiral center. Okay, is it clear everyone? This is not a chiral center. So we got 6 chiral centers. 1 2 3 4 5 6. So correct answer for this question is option C, that is 6. Is this point clear to all of you? Any doubts in this question? We got 6 chiral centers over here. Okay, great. So let's go to the next question if this is clear. This is next question, and in the question what you have to tell, which of the following will not show geometrical isomerism. Just remember the 3 conditions which we have discussed. Okay, what are the 3 conditions for geometrical isomerism? Just consider those 3 conditions and you can find out the correct answer. Okay, so which of the following will not show geometrical isomerism? Try this question. I'm giving you required time. Try out this question and use your concepts. Okay, do not just give your answer for the sake of giving it. Apply the concepts and see if your concepts are correct and your application is correct or not. Okay, Okay, so let us revise the three conditions we have for geometrical isomerism. So first condition is four terminal bonds around alkene should be in same plane, right? They should be in same plane. Second condition, they should be basically different. At least one set should be different. Okay, this is how we can analyze the conditions of geometrical isomerism. Okay, so if I take this question into consideration, so it's very simple for us to understand it. Let us see how we can solve this question. So let's start with option D. Pay attention, everyone. Let us start with option D. Okay, can I say this thing, around these two carbons we can expect geometrical isomerism? This is our stereo center part, yes or no? This is stereo center part, restricted rotation, right? There should be restricted rotation, and there is restricted rotation around these two carbons. Okay, double bonded carbons. Great. So one is this group, right? Second is this group. Now it might look to you that these two groups are similar or they are same, but can I say this thing, around this double bond also they have like two groups? Let us expand the structure. Can I say this thing, you have one CH3 over here, one hydrogen. You have one hydrogen, one group. You have one CH3, one hydrogen. Like around this carbon you have one hydrogen, one group. Okay, so like, can I say this thing, you have restricted rotation over here, right? You have restricted rotation over here. So if you have restricted rotation, first condition is like satisfied. Let's go to second condition. Four bonds should be in same plane. When n is equals to 1, they are in same plane. Okay, next condition, hydrogen, at least one set should be different. This group and these groups, these two groups are different, terminal groups are different. Okay, so over here we have hydrogen and hydrogen as common, so we can define cis and trans over here, right? Can I say this thing that this alkene is trans, right? Can I say this thing, this is also trans, yes or no? Can I say this thing, right? So we can expect GI over here. We can expect GI around this stereo center. We can expect GI around this stereo center. Let us take this stereo center into account. Now it might look that these two groups are same for the stereo center, but are they same when they can show their own individual GI? Can I say this thing, they are different now? Are they same or different? This one can show cis also, right? Because this particular double bond can show cis and trans. Okay, so like if this is trans, so like there is a possibility that this double bond is going to show cis. When this double bond is showing cis, this double bond is showing trans, so these two group becomes different. When these two group becomes different, so around this double bond we have two different terminal groups, and this group and this group, definitely they are different only because you have one substituent over here. Okay, so definitely we can say that there is a possibility that this compound will show geometrical isomerism. It is present in two places. One place is this stereo center, and second place is this stereo center, and third place is this stereo center. So you got three places for GI. First is this place, second is this stereo center, and third is this double bond. Is this point clear to all of you? It's a very nice question. Okay, so in this one molecule you have three different spaces for presence of geometrical isomerism. I hope it's clear to all of you. It kind look intense question, but if you have like good concepts, if you have understood it very well in lectures, so it's going to be easy for you to understand this concept. Okay, so like you have GI present in option D. Okay, so GI is present in option D, or this compound can show geometrical isomerism. Let's go to option B. Okay, let's go to option B. Now see, pay attention over here. If I take these two carbons, so like we have restricted rotation, first condition is verified, but what about next condition? These two methyl positions are same. Can I say GI is not present around these two carbons? Can I say this thing, it is absent around these two carbons? Yes or no, right? It is absent around these two carbons due to presence of same methyl groups. But we know one point, and that one point is whenever I have a 5-membered ring, what positions are available for GI? 1 and 2 is available, 1 and 3 is available, right? 1 and 2 and 1 and 3. Okay, these two positions are available for GI. So can I say this thing like GI is possible over here? Can I say this thing GI is possible over here when both CH3 is above the plane, when both CH3 is below the plane? So GI is possible around this region, right? Is this point clear, everyone? Can I say GI is possible over here? Yes or no? Right? It is not present over here, but it is present over here. Okay, so definitely GI is present in this molecule too. Let us go to next molecule. If I look to this molecule, what I would observe that this is methyl and this is carbon. Yes, they are different. If I go to this side, if I go to this side, they are different carbons. Okay, so this set is also different, this set is also different. Okay, 4 bonds are in plane because n is equals to 1, which is odd. So these 4 bonds are in plane, so like different groups are present, so GI is present. Great. Let's go to first option. First of all, this group and this group is same. Second concept, these two groups are also same. Can I say this thing? These two groups are also same. There is no point of difference between these two groups. So first is the correct answer for this question. Like option A cannot show GI. It cannot show geometrical isomerism. Okay, so very good, all of you. Option A is the correct answer for this question. Very good. Okay, so I'm happy to see that you are revising your concepts and you can apply it too. Okay, so let's go to next question now. Okay, so this is the next question. You have 3 carbohydrates given. You need to tell the correct DL nomenclature or DL configuration for above carbohydrates. So these are 3 given carbohydrates. You need to tell the correct DL nomenclature of these 3 given carbohydrates. It's also simple, right? We have discussed the concept. Just apply the concept and you can find out the correct answer. Make sure you remember the conditions for Fisher projection. That is what is required in this case. Conditions for Fisher projection is highly important. Without those conditions, you will end up in giving incorrect answers. Try the method of option elimination. You can find one case and you can just cancel out the given options. Then you can again you can see that which way will get closer to your answer in less time. Okay, that is the way you need to solve the questions. Okay, Shalmi is going with option A. What about others? Okay, see, like we have two ways to approach this question. Let us first discuss the way you should be approaching this question. Okay, see, what I will do now, just pay attention and listen to each and everything that is right. That is basically that these concepts will actually help you in understanding the question. Okay, all right. So Shalmi is going with A and Ajit is going with option B. Now just pay attention and look to this approach of solving the questions. Okay, see, for like this first, this is like this is first carbohydrate, this is second carbohydrate, this is third carbohydrate. Now in four options, L, L, L and L is given. Okay, that means for first carbohydrate L is given. So why I won't be wasting my time? Okay, I have to save my time when in four options L is the given answer. So I won't be checking for first case, I won't be solving first carbohydrate. Okay, so I will quickly go to the second option. So in second we have L, L, D and D. Okay, if I solve option B, I can cancel out two options. Okay, so I can start with option B now. So that way I'll be approaching this question. So if this is my option, can I say this thing? I can do 180-degree in plane rotation. Yes, everyone. Can I say this thing? I can do 180-degree in plane rotation. That is allowed in Fisher projection. Right? OH is going to be over here. OH is going to be over here. Hydrogen and hydrogen. So this is allowed in Fisher projection. Okay. Now this is okay. It's not clear. Okay, I hope this color is now clear. So now if I take this particular like 180-degree Fisher projection, 180-degree rotation and plane rotation, it is allowed. Okay, so this is going to be my first chiral center, it's going to be my second chiral center. So this is right hand side to this second chiral center, this is right hand side to the second chiral center. Okay, if it's right hand side, can I say it is D carbohydrate? Yes, everyone. Can I say that this is D carbohydrate, and D carbohydrate is present in option B or in option D? Okay. Can I cancel out two options, that is option A and C? Can I say that? Yes or no? Definitely I can cancel two options A and C because I got correct answer for option B, that is D. Okay. Let's go to next option now, that is third compound. Okay. So in third compound, what we have to do, see, maximum carbon should be on vertical line. Okay, so if this is just CH2OH, so I have to take this carbon over here. Okay, I have to take this group over here, and I have like basically I have two rotations allowed. Okay, I have two rotations allowed, so it's going to be CHO, and with respect to one chiral center only, I have to make two rotations. Okay, so this is going to be over here CH2OH first rotation, then second rotation will take hydrogen over here and OH over here. So this is going to be my compound. Okay, so first chiral center and second chiral center, OH is left hand side to this chiral center. So can I say option B is the correct answer? Yes or no? Can I say this thing, option B is the correct answer? Yes or no? Pretty simple question. Okay, so just concepts are basically required. Once you once you get the concepts, it's going to be easy for you to approach any question. Okay, I hope it's clear. Let's go to the next question. So this is your next question. 1 and 2 are geometrical isomers of each other because the correct reason for these two molecules being isomers or geometrical isomers, first is L1 is equals to L2, second is L1 greater than L2, third is L2 greater than L1, and fourth is L1 and L2 cannot be compared. Yes, okay. So can I say this thing 1, 2, 3? It's a rectangle and these four bonds are in plane, okay? It's a rectangle and these four bonds are in plane. Yes or no? Yes, in option C, L2 is given before, okay, to L1. L2 is greater than L1. This is option C, okay. Alright, so this is a rectangle. So if you have a rectangle, so this length, you're comparing this length and you're comparing this length, okay. So this length and this length, you are comparing this length and this length. So now, see, for this particular question, L2 is definitely greater than L1, but it depends that which type of rectangle you are taking. Now, if in this case, four terminal bonds are in plane, so L2 is going to be greater to L1. So option C is correct answer for this question. Okay, let us take next question. Assign double bond configuration to the following. So you have two alkenes over here. You need to define the double bond configuration E or Z. Okay, first alkene and second alkene is given in the question. You need to define EZ configuration. Yes, so the question is assign double bond configuration of the following. You have this one double bond over here, right? And we have discussed we can use E and Z nomenclature for double bonds, right? You need to define the EZ nomenclature for these two double bonds, okay? That is what you need to do. So, how we'll be solving this question? See, if I take this one double bond, see, if I take this one double bond, so can I give first priority to this group and second to this group? Can I do that? Yes or no? First priority to C double OH and second priority to CH2OH. Okay. If I go to this particular side, this is my first group, this is first group. I need to check for first point of difference, right? So this is going to be second group, right? And this is going to be second group. But with this group, I have like 1 carbon, 2 carbon, 3 carbon. It's a 3-degree carbon, and this group is a 2-degree carbon. So I need to give priority to this carbon. So this becomes first and this becomes second. When first and first they are opposite to each other or they are in different directions, this is E alkene. Yes or no? This is E alkene. Let's go to second concept now. Second alkene now. So this is your second alkene. This is your carbon. This is your carbon. Okay, so this is also your carbon, but with this carbon how you can approach it? So we got one thing that one alkene is E. We got one thing that one alkene is E. Okay, so let's erase it and let's solve option B. Okay, so if I go to this carbon is attached with one carbon and one carbon, right? This carbon is attached with 3 carbons. But if I take this carbon is attached with 3 nitrogens. Yes or no? Right? This is how I would be expanding this cyanide with nitrogen and nitrogen, right? So this carbon is attached with 3 nitrogens and this carbon is attached with 3 carbons. Okay, so first priority over here. Then again this carbon is attached with 1 nitrogen and 2 hydrogens. This carbon is attached with 3 nitrogens. So first priority over here. So 1 and 1, they are like opposite to each other, so it's going to be E. So the correct answer for this question is option C, EE. Okay, so this is how we'll be solving this question. I hope now you're able to apply your concepts. Okay, next question is, which of the following doesn't possesses a plane of symmetry? This is your next question. Which of the following doesn't possesses your plane of symmetry? You have 4 options. You need to tell in which options you don't have a plane of symmetry. Yes, okay. So how we can solve this question? Very good. This is hydrogen and this is hydrogen. This is fluorine and this is fluorine. Can I say I got a planar symmetry which will bisect this triangle from middle, which will bisect this carbon and half of this edge? Yes or no? So we got one planar symmetry over here. This is also hydrogen, this is also hydrogen. This is CH3, CH3. We got one planar symmetry over here, and we have one more planar symmetry that will bisect this hydrogen, this carbon, these two CH3 positions, right? So we have like more than one planar symmetry in this option. Okay, so if I go to this particular option, one Br is like opposite to Br, so we don't have any plane of symmetry over here. So this molecule doesn't have like plane of symmetry because we cannot bisect it, because like the mirror image of hydrogen is going to be bromine. Okay, so this is not a plane of symmetry. So if I take fourth option, one is above the plane, one is below the plane. Again, plane of symmetry is not present over here. So in option third and option fourth, we don't have plane of symmetry. So the correct answer for this question is option C. Okay, I hope it's clear. So this was like the doubt clearing session, and if you have any doubts from the concepts that we have covered in our session, so please do ask your doubts. Tomorrow at the same time, that is 7 p.m., we have doubt clearing session on mole concept. Okay, so if you want to cover lectures of mole concept, so mole concept lectures are available on Unacademy special class platform for free of cost. Okay, you can attend those lectures and you can join tomorrow's doubt clearing session and you can clear out your doubts. Okay, so don't forget to use this referral code if you are planning to take Unacademy subscription. I take plus classes, live classes for IIT JAM Chemistry and IIT JAM Biotechnology. So if you have any doubts related to stereochemistry, you can ask. So I'm waiting for your doubt. If you have any doubts, please do let me know. If you have any doubts from stereochemistry that we have covered on plus platform, so just do let me know your doubts. Okay, so right, what you can do, you can send your doubts to me, Ajit. I'll be clearing your doubts. Okay, I'll okay, yeah, quickly send in the group. I'll see your doubts. If any one of you basically you have any doubts from stereochemistry, please do send your doubts so that I can clear your doubts and you can revise your chapter with 100% efficiency. Okay, so this is basically the schedule for test series for May 2021 for IIT JAM MSc entrances, just in GAT-B examination. So GAT-B examination, so like you have analysis class, and then you have MSc entrances examination, right, previous year question discussion classes too. Then you have full length test series also. Make sure you just enroll yourself on Unacademy app, and you can join these sessions for free of cost. Okay, so if you want if you have any doubts regarding IIT JAM, you can definitely send your queries to me. I'll make sure that I answer your questions. So Arijit, please send your doubts because I'm waiting for your doubts. Okay, so I got your question now. I got your questions now. Let us start discussing your doubts. Okay, so what is your first doubt? Okay, in a tetrahedral compound, how can we identify whether ambidentate ligand are attached with it, or like COS will be present. Okay, in tetrahedral compound, how we will decide that we have to include ambidentate ligands or not. Okay, see, the thing is, in in coordination complexes only, you need to consider the case of ambidentate ligands. Okay, so if you have ambidentate ligands given in coordination chemistry, then basically you have to take ambidentate ligands into account if in options they have accounted it. Okay, if they have included those options, then you can take these ambidentate ligands into account. Okay, otherwise you have to just solve it in a simple way. Okay, so if if ambidentate ligand is given, then only you have to take it into account. If in options you have such option. Okay, if I take this example, you have metal and you have asked this question. So you need to basically this is your doubt, that how plane of symmetry, center of symmetry is absent over here. This is your doubt, that how center of symmetry is absent over here. Okay, see, if all ligands are same, okay, see, what you have to understand over here is, you have to imagine that these are bidentate ligands. Okay, they are attached with each other. So you have 4 bonds in plane. Okay, you have 4 bonds in plane, one above it like this, one below it. Okay, now just pay attention and try to visualize this molecule, that this linkage is going backside. Can I say this thing? Yes or no? This linkage is going backside from the bond which is above the plane to the bond which is in the plane, right? This is going backside. Great. Now if I take this ligand, this is in the plane and this is below the plane. This is going like this. Yes or no? So now what we need to understand, if let's suppose I have some atom which is right in this linkage, I have some atom which is in this linkage, because if I take this ligand NH2 CH2 CH2 NH2, so we have we must have any atoms present over here, like CH2 and CH2. So if I have CH2 over here, if I go to this side, I should be getting such environment over here. I should be getting such environment over here, but that is not present in this case. Okay, so whenever you have bidentate ligands in coordination compounds, center of symmetry is not present, because such environment is not present over here. Same case goes over here. If I go to this side, right, such environment is not present over here. Same goes to one more case. If I attach one more bidentate ligand in plane, if I attach one more bidentate ligand in plane, if I go to this side, I'm not getting such environment in the plane. Are you able to get this point? Are you getting this point? If I go to this side, I'm not getting such environment over here, right? The linkage is not present over here. So center of symmetry is absent. Clear? Is this question clear to you, that center of symmetry is absent over here, right? Because in bidentate ligand, such environment is not present. Okay, let us take your next question. Okay, in biphenyl system, if it's as it's flexible, so for any case, do we have to include center of symmetry or not? See, if I take biphenyl systems, so in biphenyl systems, they are flexible due to presence of hydrogen atoms over here, right? So due to presence of hydrogen atoms, this ring is flexible. So at some point of time, this ring is going to be in plane, both the rings are in plane. So in that case, we can say center of symmetry is present, right? When the molecule is flexible, so we generally say center of symmetry is present. Okay, so if someone will ask you, in biphenyl systems, center of symmetry is present or not? Yes, it is present when your groups are hydrogen. When you attach these groups with bulky groups or some organic groups, some chlorine groups, bromine groups, okay, then this definitely the center of symmetry will be lost. Okay, if it's simple a biphenyl system with only hydrogens in it, so there is center of symmetry in this molecule. But if I replace this hydrogen atom with any other substituent or sterically active groups, then center of symmetry won't be present. Okay, I hope it's clear. Next is, can we pass this type of plane? Okay, so are you saying this type of plane, if I take like 5-membered ring, A is above it, B is below it, right? B is above it and A is below it. This is the molecule. Basically, you are asking this plane which will bisect BA, BA and these two carbons. Can you please tell me? Are you asking this plane? The plane which will bisect BA and two carbons. Yes? Okay. So it's not present because like if you bisect it, you can see these two right environment are different. You have two carbons over here and you have one carbon over here. Okay? So they are not basically mirror images. Okay? They are not identical. Okay, let's take next of your doubt. If like any one of you have any doubts, please do ask over here, because like this way I can take your doubts conveniently, taking like your individual doubts on groups on particular respective groups. It's not possible because like I can't take each one of your doubt. Okay, so if I take these regular doubt clearing sessions, you can ask your doubts and I can answer all your doubts. Okay, so if you have any doubts, please do let me know. Yes, okay, so if like you have double bond hydrogen, CH3, chlorine and bromine, yes, so this plane of symmetry is present. Okay, because it's a planar molecule, so always like the plane of symmetry or the molecular plane of symmetry in your this alkenes, they are always going to be present. Okay, so yes, this plane of symmetry is present in this molecule. Okay, next doubt, if you take this molecule, if this is plane, then can we remove it by passing a plane? Then okay, I'm not getting it. Can you please tell me what exactly you're asking for this molecule? Can you tell me what exactly are you asking for this molecule? Okay. So everyone, those who are watching this lesson, and if you found this session useful, so don't forget to press like button, and please subscribe to this channel so that you should get regular updates and notifications about the upcoming sessions. Okay, so these sessions will definitely help you in clearing your doubt, because we'll be discussing concepts in plus classes, questions in special classes, and on YouTube we'll be discussing your doubts. Okay, so make sure you subscribe to the channel and you can get notifications and update about the upcoming live lectures. Okay, so yeah, so I'm waiting for your doubt. So others can also ask your doubt, right? If you have any doubts, if this is in plane, then can I remove it by passing a plane through it? Then I'm left with two hydrogens, so POS will be present. If this is in plane, then can I remove it by passing a plane through it, and then I'm left with two hydrogens? Okay, so see, alright, see, can I write this molecule like this? Now you just tell me, can I write this molecule like this? Can I draw this molecule in this way, Ajit? Yes or no? Can I draw it like this? Yes, right? Okay. Now, this carbon, right, and this carbon, these two carbons, they are in plane. This carbon and this carbon, they are in plane. Their terminal hydrogens and these two bonds, they are going to be in the plane. Yes or no? Can I say this thing? This bond, this hydrogen and this bond, they are going to be in plane. When two bonds of a ring are in plane, so for sure this ring is in same plane. Can I say this thing? This ring is in same plane. So these two hydrogens and this ring, they are in one plane only, right? And these two carbons are also in one plane. Great. So these two carbons are in one plane. Can I say this thing that this carbon is sp3 hybridized? Can I say this thing that this carbon is sp3 hybridized, right? When this carbon is sp3 hybridized, two bonds are going to be in one plane, one above, one below. So these two bonds, they are in same plane. Okay, these two bonds, they are in same plane. So one bond is going to be above and one bond is going to be below. Okay, so you can pass a plane. From in between this wedge dash combination. Okay, so a plane will come and the plane will bisect this carbon, because this carbon, these three carbons are in plane. So this plane will bisect this triangle or these three carbons. This plane will bisect this carbon also, and this plane will bisect this hydrogen and this hydrogen also. So we can pass a plane from here which will bisect all the molecules except this CH3 and hydrogen. Can I say this thing? This plane can bisect, right, all the molecules. It can cut all the atoms present over here except these two atoms, except these two groups. One is CH3 and one is hydrogen, because one is going right in front of the screen, one is going behind the screen. Okay, so it's going to bisect each and every atom except one CH3 and one hydrogen. So this plane is not present because CH3 is now a mirror image of hydrogen and they are not in right combination. Okay, so CH3 should be mirror image of CH3, hydrogen should be mirror image of hydrogen. So for sure plane of symmetry is not present in this molecule. Okay, so you can take any other plane too, the answer is going to be same. Plane of symmetry is not present because all atoms are in one plane except two groups, and two groups are not identical. All atoms are in one plane except two groups, and two groups are not identical. Okay, so the plane is not going to be present over here, right? I hope I have answered all your question. Any other question you have, so feel free right to ask your questions if you have any other question. I hope I have answered all your questions, and if you have any other question, just let me know. And all of you those who are present live in this session, if you have any other question, let me know. Clear? Alright, so I'll see you in the next class. Tomorrow's schedule is 7 p.m. mole concept, doubt clearing session. So I have covered 5 lessons on Unacademy special platform. You can go over there, you can watch these 5 lessons. If you have any doubts from these 5 lessons or any other question, so you can ask me in the next session. Okay, so tomorrow you have doubt clearing session for mole concept, and from day after tomorrow we are starting 2+ courses for biotechnology aspirant. One is chemical kinetics and one is GOC. For chemistry aspirants we are starting spectroscopy. Okay, there was a homework question in stereochemistry, so you can ask write your question. You can ask that question if you have any doubt. If you feel that you can solve that question, so then you can solve that question. Otherwise, if you feel like you have doubt in that question, you can definitely ask. So you can ask me on the group, you can send that question to me on the group, I'll answer over there. Okay, so I'll see you in the next class, everyone. Take care. I hope you found this session useful. Please do utilize these sessions, because in this session will help you in clearing your doubts, and you can practice and analyze the concepts in a right direction. Okay, so I'll see you in the next class. Take care, everyone. Bye bye.